Hello and welcome back. I would love to talk to you guys about some trig substitutions. So a lot of the time we'll end up with integrals with roots with lower order polynomial terms in them than what might be outside of the root. So what am I talking about? Let's hop into an example to see kind of what I'm talking about and how we can solve something like that. So what we have here is an x squared term in the root and an x cubed term above the root. Now, truth be told, if this x cubed was just an x, all we could do is we could use 1 plus x squared as our u and our du as negative 2x dx, bring our negative 1 over 2 out of the integral to make it the same. But we don't have that. So we know that 1 plus tan squared x, or tan squared theta, equals secant squared theta. Now, I did say x, but you'll see why I want to use theta in a second. Well, if we let x equal tan theta, then this entire root right here will just be secant theta. So let's let x equal tan theta. Our dx will be secant squared theta d theta. Well, look at that. Now, all we have to do is rewrite our integral in terms of theta. So we've got our root 1 plus x squared. Well, that's just secant theta. Our x cubed is just tan cubed theta. And our dx is secant squared theta d theta. Now we can get rid of one of each of these secant thetas, since secant theta over secant theta is 1. And now we've got the integral of tan cubed theta times secant theta d theta. I know it's written a little awkward, but just to save some time here. Now, if you watched the last video, you would know that we can actually reduce this integral down to the integral of u squared minus 1 du. Since we can change one of these tan squared thetas into secant squared theta minus 1, and our u could be let equal secant theta, our du, secant theta tan theta d theta, and this is how we would end up with this. So this integral will simply solve to become 1 over 3 u to the 3 minus u plus c. Very easy polynomial integral. Now, let's just save some space right here. Let's bring this back up to here. Let's look at our integral. Well, we've got 1 over 3 u cubed. And remember, our u was secant theta. So 1 over 3 secant cubed theta minus secant theta plus c. What's secant theta? Well, we can't find this out directly from up here, can we? Not directly, but our x squared plus 1 equals secant theta, secant squared theta. So secant theta will equal root 1 plus x squared. Because this could just become x. Get rid of the square here, square root both sides. Secant theta equals 1 plus x squared. Of course, I forgot that squared. Silly mistake. Everyone's going to make them. Just got to know how to catch them. So what's this? Well, this is just 1 over 3. Secant cubed theta is just this cubed. This is 1 plus x squared to the 3 over 2. And this is just root 1 plus x squared, plus c, of course. And that's what I got before I started this video. So I continue to look down at this sheet. Make sure I don't make any mistakes, teach you guys anything that would not be true. That wouldn't be very great. So, that's one of the integrals we could have. Let's take a look at another one. Now, this one, it would be possible to just solve this one regularly, but let's do it the fun way. Integral of root 1 minus x squared over x dx. And the reason I'm going to do this the fun way is just to make sure that you guys know what it looks like when you have 1 minus something or 1 plus something under a root, what types of substitutions we could use. Say this wasn't a just regular x. Of course, this was the integral I talked about at the start of the video where we could just use a simple u substitution. So let's remember that sine squared theta plus cos squared theta equals 1. Well, that means that 1 minus either sine squared theta or cos squared theta would equal the opposite squared theta. So, I think in my, yes, I used x equals sine theta. Sine theta. So 1 minus sine squared theta or 1 minus x squared equals cos squared theta. We root both sides because that's what we have in here. We just have a regular cos theta. So let's find our dx term. Let's differentiate both sides. That's just cos theta d theta. What do we have here? We have the integral of sine theta over cos theta. Dx is cos theta d theta. So this is actually just the integral of sine theta d theta. Well, what's that? That's easy. That's negative cos theta plus c. What's our cos theta? That's root 1 minus sine squared theta, or root 1 minus x squared, because our x equals sine theta. So this is negative root 1 minus x squared plus c, which we could have gotten just from doing a simple substitution, but this is the fun way. I hope this video helped. I wish you all luck with your trig integrals. I hope that both this video and the video before this helps you a lot with these types of integrals and solving these types of integrals using your trig substitutions, or not trig substitutions, your trig identities, such as these. And good luck. I will see you in the next video where we will talk about a very, very fun integration technique, probably one of my favorites. Thanks for watching.